Good afternoon. Today is EarthX. It's great to be here at the conference, and I'm here with John Sterman, the J. Forrester Professor of Management. J. Forrester was a legendary person, and John is the head of the Systems Dynamics Group at MIT, which is an extraordinary body of science. And we're going to see one of the things that systems dynamics allows in real time. I'm here because I'm a former MIT student and worked with John over the last decade, bringing the model we're about to see to about 300 governors, senators, and congressmen, and many leaders. This is one of the leading global models that models globally how climate is advancing, what are the drivers of climate, and what can be done to fight climate change. We're going to start, you'll see on your screen shortly, two screens on the left side and the right side, almost like two TV stations, if you will. And just quickly, the model is in 3.3 degrees centigrade. That means if we do nothing for the next 50 years to 2100, what we will have is 3.3 degrees centigrade, which would be a disaster. And everything we're doing now is to bend the curve. What are the policies, what are the actions we can do to bend the curve? And maybe, John, if you want to talk about the three sections on the bottom, energy supply, use of energy, and a few extra dividends. So why don't we start from there?
Great. Well, thank you, Michael, and thanks everybody for being here. Michael is, of course, much more than an MIT alum. He's been a critical supporter and enabler of the work you're about to see, which we have done by developing this in our group at MIT and in partnership with Climate Interactive, which is a nonprofit, nonpartisan think tank. And of course, MIT is nonpartisan and nonprofit. We're based on the science. And what we're going to show you is, and have you all help, Michael will help, build a safer world by getting us from that 3.3 C, 6 Fahrenheit trajectory of catastrophe that we're on down to well under 2 degrees. And so how are we going to do it? Well, first of all, the model is completely free. Anybody can use it anywhere in the world. You just go to en-roads, en-roads.org, and there it is for you. It's available also in 21 languages. We're going to go in English, though, and time is limited. So what you've got on this side is total global primary energy use and where it comes from. So the brown band at the bottom, that's coal. Red is oil, petroleum. Then we have natural gas in blue. Wind, solar, hydro, geothermal, other renewables in green here. Different ways to make bioenergy in that pink, and nuclear power on top. Don't really have time to go into it, but the model's carefully calibrated to the history across dozens and dozens of variables. Here you can see the marginal cost of solar PV, and here you can see how the model replicates the history of global warming. But what we want to do in this limited time is we want to bend that emissions curve that you see here. You've got all this energy here, and the baseline is continued dependence on fossil for the rest of the century, even while the renewables grow. So that leads to growth in total greenhouse gas emissions from CO2 from burning fossil fuels, the biggest, methane from industry, from the energy system, from agriculture, from deforestation in green here, and then nitrous oxide and fluorinated gases. So,
and John, just to interrupt, some of the greenhouse gases are coming from things other than fossil fuels. So as an example, just a quick snapshot on agriculture. Agriculture is not, well, for part of it is, but the methane that's produced from the rotting, what is that about?
Right, so there's a lot of methane emissions that come from different sources. You can see here from energy, that's a huge chunk of it. That's leakage from oil and gas wells. And then from agriculture, that's huge. And then also from waste, decomposing waste. So yeah, and the model's got a huge amount of detail you can drill down into, but let's start solving the problem. So Michael, here at the bottom, we can change the actions and policies on coal or oil or gas, bioenergy, renewables, nuclear. We can try out what if there was a breakthrough in fusion power. You could put a price on carbon. You could speed improvements in energy efficiency, in transport, in buildings, in industry. You can electrify end uses.
Here
we have nature-based solutions for carbon dioxide removal.
So let's just kick off, because I'm an investor in an MIT-related activity, Commonwealth Fusion. And is fusion going to solve the problem?
Well, let's ask the audience. Raise your hand if you think a breakthrough in fusion power today would really help solve that climate crisis. Got to raise your hand if you think yes. Thumbs down if you think no.
Okay.
Okay, well, let's try it.
Let's see what happens.
So right now, here's the energy mix. Let's really crank it over a big fusion breakthrough right now today. Well, we made 1/10 of a degree of difference, not a whole lot. So how come? Well, one reason is, even if the breakthrough is today, which that would be great, but nobody's expecting it, it takes a long time to the first commercial plant and an even long time to scale it up globally. And look what happens to the renewables when it hits the market. Coal goes down, gas goes down, but so do the renewables. So your fusion power is too little too late, and it cannibalizes the other zero emission sources.
So you have a similar function, because people are talking about these small nuclear power plants, and nuclear, if it's heavily subsidized, will have what impact?
Well, let's try it. Let's subsidize nuclear. Huge subsidy for nuclear. Another 1/10 of a degree of benefit, way more nuclear. Here you can see nuclear in the base case, and then with the huge subsidy, we get a huge amount more nuclear. Similar story, takes a really long time to build them, and in the meantime, you're still burning all that fossil carbon, and you're squeezing out your other renewables, so you're cannibalizing other critical parts of the solution. So expensive, not very effective.
So just as an example, for free marketers, for people who believe in the market, what's the failure of the market, even with nuclear, is to subsidize renewable, because renewable can't fight economically with fossil fuels. No matter how much nuclear reduces it, you'll continue to burn fossil fuels without some kind of subsidy.
Yeah, if we heavily subsidize renewables, we get another 1/10. And the big problem here, you just stated it, we would like to harness the power of markets, but there's a huge market failure, and that is, of course, we don't price the damage from the carbon emissions. So,
well, when you talk about it, people say that there's a difference between the fossil fuels. Coal is the worst and gas is the best, and can we use more gas and get rid of more coal? So let's start with ways we can work down the coal community.
Okay, so we could heavily tax or regulate or penalize coal. Here we would simply ban the construction of all new coal infrastructure. Well, that got us 2/10 of a degree, but the coal lasts a long time. We're just banning the new stuff. We could do more, but it's a heavily regulatory approach, right?
Let's just stop for a second. We're at 3.1 degrees centigrade. We started at 3.3. We have to get below 2. That's the magic number. Think of it as steps, 12 steps. With everything we've done, we've only done 2 steps so far. So we haven't even come remotely close to getting below the outer limit of what scientists believe will be catastrophic change. We're not having much of an impact.
Every 1/10 matters, but there's a long way to go.
So how about if we just stop coal completely today? Can you just shut off coal?
We can.
It's not realistic,
Not
though.
realistic. So we could simply force the shutdown of existing coal plants.
And you're seeing in the top left, the brown line go to zero under the red.
No,
That's cutting down coal.
We're not turning it off instantly, because that would cause enormous economic harm. We're phasing it out over a few years to zero, and it got you another 1/10.
So you have the oil use. Oil use is primarily hasn't come down yet because you still have transportation as a critical use of oil. And what's the number one way to reduce oil use in transportation? Electric cars. So how about if we focus on electric cars? Of course, we will get to electric planes, we will get to electric boats, but electric cars is the number one thing. So what if we really knock it off on electric transport?
All right, so we're at 3 degrees, and let's heavily subsidize electric vehicles and the charging infrastructure. We're getting a lot more EVs on the road, a lot faster, but it's another tenth.
Kind of surprising because you'd think it's a much bigger impact, but actually the US grid is way ahead of China and India. China and India are still producing electricity from coal. So if you take coal-produced electricity and put it into an electric vehicle, you're not getting as much of a bang for the buck. So how we tried it with the coal, maybe the next thing we have to do is just raise the price of oil or reduce the use.
Great. So here's what I'm going to do. Let's go back to the base case, reset, and let's try closing that big loophole that we don't price the harm from putting carbon dioxide in the atmosphere.
So that's a carbon tax.
That's a carbon price. I'd rather say carbon price because it doesn't have to be a tax. It could be cap and trade. And do you have an idea, Michael, how big of a price?
Well,
the global
I'd
average
like to start at $100 a ton. That seems like the lowest amount that will have a big...
89 cents on a gallon of gasoline.
Yeah, just, did you hear that? $100 a ton, which is the highest level that people talk about using, is a big 89 cents a gallon on your gasoline. We have gas prices fluctuate more than 89 cents in a year, and nobody is crazy about that, but 89 cents. So what does a carbon tax do?
Well, let's find out. We're at 3.3 without anything and 2.9. This is a huge high impact policy. So
that one policy had 4 times the impact of all the other individual policies we talked about. And it harnessed the market. That's the most important thing from an innovation point of view.
Nobody's telling you what kind of car to buy or how much to fly or how to heat your house. You're free to make your decisions. So this is the freedom preserving policy, unlike you cannot do this, you cannot do that. It also penalizes coal more than oil, more than gas, and encourages renewables and efficiency. There's one big problem though, and that is it would be regressive. It would hurt low-income folks the most. So there's a very straightforward answer to that, which is you take every dollar of revenue and you give it back to the people. That's called a carbon dividend. And you know, I give a lot of talks like this and people say, never gonna happen. Well, guess what? It's happening already around the world right now. Here's the World Bank's carbon pricing dashboard. There's 110 countries and other political jurisdictions in the world that have carbon pricing, and Canada has this carbon dividend policy. So if you're Canadian, you get a check 4 times a year, your share of their carbon tax, carbon price revenue. It's called the carbon rebate.
In other words, putting a carbon price affects behavior. What you do with the money is what you could do. You could rebate it, you could reduce government. One of the beautiful things about a carbon tax is you can reduce the size of the EPA because you don't need regulations to reduce carbon. You can do it using market forces.
Okay, so we still have a ways to go before we get below 2, Michael.
So we didn't do too much on oil, and what about gas?
Well, there's still some gas there, but...
We've taken most of it out with the carbon price.
Yeah, but let's not focus too much on the energy supply side.
Use of energy.
What do you think we might do over here? Yeah.
Well, a lot of this is tied to population growth and economic growth because of population. And if you put the 4 charts up, it just shows what's behind the model. As the world develops, there are more people. As there are more people, the average wealth goes up. As the average wealth goes up, people want more air conditioners, they want more cars. So you have this chain of events that starts with population growth, but economic growth also. So is there any way to curtail that? What would be a policy to curtail that?
Well, I don't think we want to slow down economic growth. In fact, if we solve the climate problem, the economy should grow faster because it won't be hampered by all the flooding and extreme weather and migration and conflict and war. So let's try boosting efficiency even more than what the carbon price does for it. It's already helping, but let's improve, speed up efficiency growth in industry and the built environment. That's huge. That's another couple tenths.
Energy efficiency is triple glazed windows, it's more efficient systems. But now let's electrify. Take all your oil and gas heaters and turn them into electric heaters.
Great.
What kind of impact does that have?
So we've taken a lot of the coal out of the system, and so now if we electrify industry and vehicles, now we're down to 2.5. So making a huge amount of progress here.
Now
What
we
else?
didn't do anything about agriculture, and agriculture is almost between 25 and 30% of CO2 production. So what can we do there?
Let's put in more sustainable, low-emission agricultural techniques, so no-till, low-till ag, using manure instead of synthetic fertilizers. There's a lot that can be done, more locality in your
What
crops.
about what methane leakage at oil wells?
Great.
And
So it's already down some because the carbon price means we're not using as much fossil, but we could do even better. So there's 2.2, and I'm not
Now-
pulling the levers all the way. There's still some headroom there. 2.2.
keep in mind the methane was a huge lever, because methane is what, 30, 40, 50 times as bad as CO2. So if you can contain small amounts of methane, the leveraging impact is huge. We're going to take it because we're going to run out of time. What about deforestation? You know, what's going on in Brazil and all
Great.
of these other places.
So it's actually falling a little faster in the out years. That's because with less warming, we don't need, crop yields are higher, we don't need to cut down as much virgin rainforest to feed ourselves, but we can do a lot better. And we don't have to cut it all the way, but there's 2.1. And then, you know, how about let's reforest some of what we've already lost.
Yeah.
So we can, let's do that. And there's 1.9 degrees.
Okay.
And, you know, that's a much safer world. Now, what is it all going to cost? There's definitely costs to doing this, but there's huge benefits. So if you look at the base case, that's sea level rise. If you look at the base case, there's a lot of drag on the economy. This is real GDP per capita, and the dashed line is what it would be if climate had no impact, which we know is wrong, and the solid line is how much we're losing because of the 3.3 trajectory. In our simulation at 1.9, economic growth is much higher. So even after you account for all the costs of the transition, you have a healthier, safer economy for everyone.
What's the one takeaway? Yeah.
May I suggest simulating the impact of switching to whole food, plant-based diets, and show me what the agriculture...
So the suggestion from the audience is, what if we eat less meat? I assume that's what you're talking about, because meat is a huge contributor that most people don't realize the impact of flatulence from cows, the internal...
Cow burps.
Cow burps, if you want to call it. What is the impact?
Well, so this lever is people shifting towards a more plant-based diet. And, you know, to get that down that much would be...
You know, if you can move
that's
one step we just did, that's mind-boggling.
That's a heavy lift, though,
But
to get
John,
people to
there's
stop
a
eating those
takeaway with
burgers.
all of this. If
Yeah.
you can go back to the front piece. Yeah. What the takeaway here is, can you go back to the page with all of the pieces?
Yep.
There's two takeaways. One, it's doable. We have the knowledge today how to do this. But the second thing is, look at the amount of policy integration across the globe that would be needed. Would you rather know how complex it is, or that it's doable? Which is the better statement for all of you? Doable.
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 Great.
That's what it is. When we talk to leaders who don't have the detail of this, the fact that there is a set of scientific solutions that they could work towards is the revelation. And that's what this model helps you figure out, what the relative benefits of that are. Any last thoughts, John?
Well, last thoughts are, this isn't the only way to get where we want to go. Encourage you all to try it yourselves. It's completely free. You go to that website, n-roads.org, or you go to the MIT Climate Policy Center, where you can learn how we're bringing this to leaders around the world. And here's how many people we've been able to reach so far: 440,000 folks in 178 countries. How does that happen? That happens through our network of climate ambassadors, volunteers who have learned how to run the model in workshops with audiences all over the world. You can do that yourselves. All the training materials and other help you need, free on the website.
And the model is not only open and free, you can get under the hood to the 38,000 individual variables and calculus. So if you think the sensitivity of one thing is more or less because you have a science, you can put in your own assumptions, and what you'll find out is within any reasonable ranges, the conclusions are relatively consistent. This is a complex problem. It needs a lot of policy, but it can be done if we get going. We're right now a little going backwards, but it can be done, and we have to do what we can do. Thanks so much, John. Great to be here.
Thank you, Michael.